Hello grade 11s and welcome to the very last part of question number 3. These questions deal with concentration of a solution as well as an acid-base neutralization reaction. So please make sure to pay attention to these questions. So the first question says a solution of potassium hydroxide, that is KOH, which you now know is a strong base, is prepared by dissolving 3,36 grams of crystals of potassium hydroxide in 250 centimeters cubed of water. So we have the mass of the solute and we have the volume of the solvent. They say calculate the concentration of the potassium hydroxide solution. There are two methods you can use. You can either say N equals M divided by the molar mass, and then say C is equal to the number of moles divided by the volume. So you can plug that number of moles into this formula. Alternatively, you can do everything in one step, which is exactly what I'm going to do. I am instead going to say concentration is going to be equal to the mass divided by the molar mass multiplied by volume. The mass in this formula is the mass of the solute, the potassium hydroxide. So we're going to go ahead and plug that in as 3,36 grams. We're going to divide that by the molar mass of the potassium hydroxide. Potassium has an atomic mass of 39. Oxygen is 16 and hydrogen is 1. So in the place of the molar mass, we have 39 plus 16 plus 1. Okay, that is the molar mass of potassium hydroxide, and the volume is going to be the volume of the water, the solvent. We substitute volume in decimeters cubed, so that's going to be 250 divided by 1000 or times 10 to the negative 3. So we're going to take all of this and we're simply going to plug it into our calculators, and in the end we find out that the concentration of this potassium hydroxide solution, so concentration of the potassium hydroxide solution is given as 0,24 mole per decimeter cubed. And make sure that you have the correct SI unit here, or otherwise you're not going to get your marks. You're going to be awarded 1 mark for your formula, 1 mark for your substitution, and 1 mark for the final answer. If you use these two formulas, then you get 1 mark for the formulae on condition that both were used correctly. Now we can go on to question 3.4, and this question says 25 centimeters of potassium hydroxide solution of concentration 0,25 mole per decimeters cubed completely neutralizes. That means it reacts completely in a stoichiometric ratio with a dilute solution of sulfuric acid. And we know sulfuric acid is a strong acid because we've learned our strong and weak acids and bases off by heart. They say the unbalanced equation below represents the reaction that takes place. We have sulfuric acid reacts with potassium hydroxide to form potassium sulfate and water. Remember, when an acid reacts with a metal hydroxide, that is a base, specifically a metal bonded to hydroxide, it's going to form a salt and water. This is an unbalanced equation. Question 3.4.1 says that we should balance this chemical equation. This is a skill that you should know from grade 10. We're going to have 1 mole of SO4 react with 2 mole of potassium hydroxide to form K2SO4 plus 2 mole of H2O. In this case, you're going to get 2 marks on condition that the entire equation is balanced. Now that we have a balanced equation, we can go on to question 3.4.2, which says calculate the mass of sulfuric acid in the flask. So in this case, we have a whole lot of information about the potassium hydroxide. We know the volume of the potassium hydroxide is 25 centimeters cubed, and we know that its concentration is given as 0.25 mole per decimeters cubed. We have a balanced chemical equation. So what we can do is we can start off by determining the number of moles of the potassium hydroxide. And once we know the number of moles of potassium hydroxide, we can use that to determine the number of moles of sulfuric acid and then the mass of the sulfuric acid. So concentration is equal to number of moles divided by volume. Therefore, we can say that the number of moles of potassium hydroxide is going to be equal to its concentration multiplied by its volume. The volume must be substituted into the formula in decimeters cubed. So we have 0.25 multiplied by 25 times 10 to the negative 3, or you may divide by 1000. In the end, we find out that the number of moles of potassium hydroxide is given as 0.00625 mole. We don't round off to 2 decimal places. We keep a few more decimal places because we are not yet at the end of the question. Now that we have the number of moles of potassium hydroxide, we can say sulfuric acid to potassium hydroxide according to the balanced chemical equation reacts in a ratio of 1 to 2. We have available 0.00625 mole of potassium hydroxide, and we do not know the number of mole of sulfuric acid that will react with it. We cross multiply, and over here we say 2 times x. We divide both sides by 2, and we find out that x is going to be equal to 0.003125 mole. This over here is the number of moles of sulfuric acid. So now that we know the number of moles of sulfuric acid, it is possible for us to calculate the mass of the H2SO4. Because mass is going to equal to number of moles multiplied by the molar mass. The number of moles is 0.003125. The molar mass is going to be 1 times 2, that is the hydrogens, plus sulfur has an atomic mass of 32. So we say plus 32 plus 4 times 16, that is the hydrogen atoms. And in the end, or if you'd like to, you can sub in a molar mass of 98, that's also going to work. But in the end, the mass of the sulfuric acid is 0.31 grams. And that is the answer to this question. So in this question, you're going to be awarded 1 mark for your substitution to calculate the number of moles of potassium hydroxide, 1 mark for the method that you used to calculate the number of moles of sulfuric acid. 1 mark was awarded for the formula, for substitution into the formula, and for the final answer of 0.31 grams. That gives you 5 marks for question 3.4.2. And grade 11s, this brings us to the end of question number 3. In the next video, we look at question number 4, which is a question involving ideal gases and Boyle's law. I hope that you'll join me there.